In this video, we're going to first introduce a rectangular coordinate system, which is also called Cartesian coordinate system. The reason we call it Cartesian coordinate system is because this system was invented by a mathematician whose name is Descartes, and so that's why it's also named after him. So remember that when we talked about number lines, so we can draw a line and put all the numbers, all the real numbers on the line. So you may have 0 in the middle, and you may have on the right side we could put a 1 and 2 units and 3. On the left hand side we could do negative numbers, just like when you look at a thermometer, -2, -3, and -4, and so on. And so this will go on forever. And but we can also, but we because we live on the a sphere, it's a plane, and so when you're moving, we're not just moving on the straight line. So we can move up and down and anywhere. So we really need a two-dimension system to determine where we are. So like the GPS system, and in order to locate where we are. And also we learning geography that you have longitude and latitude to determine a place. And so Descartes' idea is to draw another vertical line to intersect with the horizontal line we have. Let's draw another line here, and this is the idea that it was a story that he invented this because he was lying in bed and he saw a fly crawling on the ceiling. And to determine the movement of the fly, you will need two numbers, and so that's why that gives him an idea to create this coordinate system. So we call the horizontal line x-axis, and we call the vertical line y-axis, and we can let's say. Similarly, on the vertical line, on the y-axis, we can also mark the units. When we go up, we have positive numbers, and when we go down, we have negative numbers, -1, -2, -3, and so on. So it will also go on forever. Now, for example, if a fly is moving, let's say it's right at this spot right here. And you may pick the corner. Where's the intersection point? You can pick the corner of the wall as the as 0, which is, we also have a name for this spot, right? This point right here, the intersection of these two axes. We call it origin. So in real life, if when you're tracking the movement of an object, you may have to determine to use pick a place as the origin. So suppose so with respect to this origin, suppose a fly is right here, and how do we determine where it is? There are two numbers, so we are starting at this point and go down. We will see horizontal movement will be 1 unit, so with respect to the origin, but vertical movement is 2 units. And so it's sort of like over 1 up 2. And notice there is an order for this. So you would put a 1 and 2. We cannot switch them, because if you switch them, you get a 2 and a 1. And 2 always means the horizontal distance, the over. So you do 1 and 2, and you go up 1. So that will give us 2, 1. So this is an ordered pair, and the order does matter. When you change the first number and the second number, you will get a different spot, different place. So with this, we can determine the movement of any object and anything. And we can, if you say these two numbers, we know where you are. So for example, if you say my location is 3, 3, and then I just have to move over 3 units and up 3 units. So that gives us 3, 3. So we know we can find you exactly. And so similarly, we could have negatives. What if it's on the other side of this origin? So we could have negative numbers. For example, this point right here will be to the left 3 units. So that would be a negative 3 and up 1 unit. But if we go down, we may have this. Look at this point. We go down. First, we always look at the horizontal disk movement. So go to the left, negative 2, and you go down negative 3. Always write down the horizontal number first. And we can call the first number x coordinate. There's another name for that, but it would be easier just to call the first number x coordinate and the second number y coordinate, which represents how far it is from, and also the direction from the 0, the horizontal and the vertical distance. And now we, why do we have the system? So we have this actually, the calculus with the system created. The calculus was invented by Newton and Leibniz, and because calculus studies functions and the movements of objects, and so with this we can track any moving object. Okay, so next we're going to look at the easiest function, or you can also call it an equation. So we start with a 2-variable function. For example, if I have y equals 2x, let me change it to 3x plus 2. And this is called an equation. Later, when we study function, this is also called a function. So the reason we call it equation is because also it has an equal sign there. But the difference is from the previous equations we studied, we have 2 variables. And previously we did study equations. We have, say, 3x squared plus 2x equals 7. And as you can see in this equation, we only have 1 variable x. That's the same x, although they have different exponents. But in this equation, we don't have x squared, but we have 2 variables. One is x, one is y. So how do we solve equations like this? And we can use the coordinate system to help us understand this equation. So the first, as you can see, we can pick different numbers for x and y. If I pick a number for x, let's say let x be 1, and I can plug 1 into the equation. 3 times 1 plus 2, that will give us a y equals 5. So 3 times 1, because x is equal to 1, plus 2, and that gives us 5. So that means if we pick 1 for x, the corresponding y will be 5. And similarly, we can pick a different number. Say, what if we pick a negative 1? And then we get a different y. 3 times negative 1 plus 2. And that is equal to negative 3 plus 2. That's negative 1. And we can also pick any number. I didn't pick any fractions because fractions are not easy to work with. That's why I all picked whole numbers and integers. So let's pick 0. If I pick 0, y equals 3 times 0 plus 2, which is 2. If I put all these values that I picked a few. You can keep doing this. Say you can pick 2 for x, 3 for x, or you can even pick fractions if you want, like 1/2 or 3/5, or decimals. But it's always easier to pick integers. So let me put all these values in a table. So I will create one column for x and another column for y. And I'm going to put the numbers I got. So when I pick 1 for x, I plugged 1 in there. I got y equal to 5. So they are a pair. And then, but when I picked the -1 for x, I got a -1 for y. And then when I picked the 0 for x, I got 2 for y. We can keep doing this. And see, it's easier to pick a number for x. If you want to pick a number for y, you should be able to also find a value for x, but you have to solve the equation. Let's say, how about we pick 3 for y, see what happens. So if we let y equal to 3, so that means when you plug in, you have to replace this y with the 3, then equals 3x plus 2. Then we're going to have to find the x, we have to get x by itself. But we've already learned how to do this. Just subtract 2 and divide by 3 both sides. So that gives us x equals 1/3. So if we pick 3 for y, second column, the corresponding x will be 1/3. Okay, so it looks like to solve a two-variable equation, when you have both two variables, x and y, you may have many solutions. And so the first pair, 1, 5, can be a solution. And second pair, -1, -1 is another solution. 0, 2, another solution. 1/3, another solution. We can keep doing this forever. So we have infinite many solutions. So that's something very different from the equations we solved before. Previously, we either had one solution or two solutions or three solutions. We never had infinite many solutions. But when you have two variables, it's possible that you have infinite many solutions. If I put them in an ordered pair, 1, 5, and -1, -1, and 0, 2, and 1/3, that corresponds to what we just discussed, the points in the coordinate system. And so we can actually plot these points in the coordinate system. So I'm going to draw another coordinate system. That's x-axis, and we draw a y-axis. And in the coordinate system, we're going to put those points there. So when x equals 1, y equals 5. 1, you're going to go up to, say, 1, 2, 3, 4, and 5. Over 1, up 5. So that's 1, 5, the first point we got. -1, -1. So x equals -1, right? Y also equals -1. So we got left -1 and down -1. And the third pair is 0, 2, when x equals 0. So if x is 0, it's right here. We don't have to move right or left. But y is equal to 2, so we move up. That's the point we have. Let me mark it. This is -1, -1. This is 0, 2. And we have 1/3 and 3. So 1/3 is somewhere here and up there, 3. Now, when you look at all these points I plotted in the system, we can keep doing this, picking more, and you will find that if you join all these points, you are going to actually get a straight line through the points. All right, and so the reason, if you pick right now, I only picked 1, 2, 4 points. If you pick more, you will see all of these points will fall in this line, and some of them might not be very well plotted. And so this, as we said before, when you pick numbers, you can pick infinite many numbers. Each pair will give us a point on the plane, in the coordinate system. So when you keep picking this, you're going to get infinite points. So more points, more points, more points, infinite many points. All these points will form a straight line. So go up forever and go down forever. So as you can see, algebraically, it's an equation. So this is an equation in algebra. But after we pick numbers, we put all the solutions, infinite many solutions, each pair is a solution. In the coordinate system, we got a straight line. So this is more like a geometric view. So the good thing about the coordinate system is Descartes, he connected geometry with algebra.